Hello guys, my name is Siddhant Parekh and my teammates are Hardik Panchal and Soham Patil. And our topic for research paper is Moore and Mealy negative edge detector using finite state machines which is implemented in VHDL. So let's get started. So in modern society, we are more dependent on computerized technology. The automatic machines perform a variety of operations by adapting the changes in the physical environment. So here in this, we have two varieties of FSM that are Moore and Mealy. So before getting started with Moore and Mealy, let's understand what is FSM and how it works. So FSM is which changes from one state to another due to applied external inputs. The change from one state to another state is called transition, and FSM is defined by a list of its states. It has its initial state, final state for each input. So how does it work? So as you can see in the right side, there is a general FSM model. So the bubble indicates state and arrow indicates the direction from state to state. The state machine has present state and next state when the clock signal is applied. FSM is classified into two types. They named as Moore and Mealy machines, which we will see in next slide. So on the left, there is a Moore machine with its block diagram. So what's a Moore machine? Finite state machine is said to be a Moore machine if its output depends only on the present state and it has no relation with input. For generating the outputs, it considers the clock. On the right hand side, we have Mealy machine definition and its block diagram. So a finite state machine is said to be a Mealy machine if its output depends only on the present state and present input as shown. For applied input, it can generate a variety of different output patterns in the same state. So we have an example and it will be explained by Hardik.
Okay, so now I'll explain the example. The FSM working process is explained by designing the negative edge detector circuit. Sign FSM can be used in the automata applications like vending machines. This circuit generates one pulse for each clock cycle, which is called as a tick when the input changes from logic low to logic high. Now, the functionality is frequently employed to indicate the high to low transition of a slow time varying input signal. And now we will be implementing the same using Moore and Mealy state machines. So next slide. Okay, so here we have a falling edge detector state diagram based on Moore state machine. So what happens here is that we have 0, edge and 1 as the states. The level is given as input where level is equal to 1 and level is equal to 0. The tick is applied and specified as an output. When the input is low in state 1, then falling edge occurs and output ticks becomes 1. And then the FSM state changes to edge. Okay, so this was the working of this particular diagram. Next, we move on to the next slide. Now here, this diagram indicates the falling edge detector based on a Mealy machine. Here the states are same 1 and 0, and we have the level or tick which is less than equal to 1. So here the FSM changes to state 0 and output tick becomes 1 in this state. So this was about the working about these two state diagrams. Now next slide. Now these two Moore and Mealy state machines are based on the previous diagrams which we have just seen. Two Moore and Mealy state machines are shown here based on the previous diagram which we have seen, and we have tried to implement the same using VHDL in Genelec software. So we can see here we have a register transfer level RTL schematic diagram for the falling edge detector on Moore and Mealy machines. So now my friend Som will explain the further part of this.
We have designed the state diagrams for Moole and Mealy machine previously. Now we have tried implementing the code in Model Sim software. Now I will explain the code. We have tried implementing the same Moole and Mealy circuit in VHDL using Model Sim. First, we have created input for clock and reset in standard logic, level which is transition input in standard logic, Murray out and Mealy out in standard logic as well. For creation of architecture of state of Mealy, which can be divided into 0 and 1 states. State Mealy register is the current state of the Mealy machine, and state Mealy next is the next state of the Mealy machine. State Murray type can be divided into 0, edge and 1 for Murray machine. State Murray register is the current state of the Murray machine. State Murray next is the next state of Murray machine. Now the process begins for Mealy machine. First we have to assign the current state of Mealy machine as the next state and Mealy out as 0. If the current state is 1 and the transition symbol is 1, the next state is assigned to 0 and the output of Mealy machine is given as 1. If the current state is 0 and transition symbol is 1, the next state is again as 1. And for Murray machine, again we have to register state as the next state for the current state, and Murray out is initially 0 when the current state is 1 and the transition symbol is 1. If the current state is edge and Murray out is 1, the transition symbol is 1 and next state is 0, else the next state is 1. If the current state is 0 and transition symbol is 1, the next state is 1. We have tried implementing the waveform for the same. We can see transition of 0 to 1 for Mealy machine and 0 to 1 for Murray machine. We can see Mealy out and Murray out here if the level which is transition symbol is 1. The previously shown waveform showed the transition of Mealy and Murray machine for the given design. Still there are some differences both the state machine. The Mealy based design responses quickly than Murray state machine because it requires lesser states and does not wait for clock for generating the output. For asynchronous system implementation, Mealy machines are not suitable as Murray machines because a small change in the input correspond to change in output independent of the clock and it may lead to instability of the system. Conclusion: in modern times, we are more depending on computerized machines. In this finite state machine like Murray and Mealy machine, based negative edge detectors, state diagrams are designed and tried to implement using model sim. The timing diagrams are verified and RTL schematics are also generated using it. Here the comparison is made between Mealy and Murray finite state machine based on timing diagrams of state machines. Thank you.